Assalamu alaikum and good afternoon. Ramzan Mubarak. Dear friends, welcome to our another video, Introduction to Dynamic Analysis and Earthquake Engineering. Loads, there are so many type of loads, and major loads which act on the body or on any structure, they are static loads. Static loads generally are such loads which continuously stay on any structure, such as dead loads, self weight of any item, and we can also say that their application will be slowly on the structure. Whereas dynamic loads, they apply suddenly with accelerations, such as blast loads, wind loads, earthquake loads. In this tutorial, in this presentation, we will go and we will read about these wind loads and earthquake loads, how they will be considered and how they will act on any structure. Blast load is a different subject which will be having a very huge impact on the cost of the structure. If you want to design for a blast load, so we cannot use normal softwares. We have some special softwares for these blast loads, where you need to consider this amount of this blasting material and the impact. You have to study the impact for the time, and inshallah in the future I will make one video for this blast loads also. Wind loads, when we see any structure or any shed, we have a wind effect on it. If the wind load is such that it dominates the self weight of the structure, it will blow away your structure. One of my brother, he has recently, almost 3 4 years before, he has normally constructed one frame structure without considering the wind load. The very next day, due to a huge wind around our Guntur, this structure has been blown away. And he, especially when wind load considered, so we have Indian codes, American codes, so they have a special explanation for these loads. We have one is a empirical way of applying the wind load on any structure. And some structures, like they are very construct very high rise structures, such as Burj Khalifa and some other structures, like which are almost 1 kilometer from the ground level, where you have a huge wind impact. Those structures, you have to do dynamic analysis for that, and where you will study its drift due to the wind. And there is a certain value of allowable drift for any structure. If it is crossing that, then again you have to design your structure. Especially wind structures, steel structures, for wind loads, steel structures will have a huge impact, unless if they are not high rise. If high rise structures are there, then even you have to do analysis for the wind loads for the concrete structures also. And there's one test is there, wind tunnel test, which you have to do, for example, empirical way of applying wind loads to the structure. But this tunnel test, you have to do for such structures which are high rise structures, and even sometimes you need to study a whole city, how this wind is going to affect that. So in terms of area, in terms of height, when you are when you are not it is not just limited to a single structure. When you are studying a whole area, then, and also due to the height, high rise structures, then wind tunnel test will be used to understand the wind loading. Now earthquake loads, friends, earthquake loads, recently we have got earthquake effect in Afghanistan, Pakistan, and also we have experienced some vibrations in Delhi, New Delhi also. So we should be, these loads are very they are very critical loads, which may hit in your which may hit your building at any time. so you should get ready. And here in the earthquake load, so you have some at any point you will be having some epicenter. From that epicenter you are the plate, especially this is the energy will be released due to this movement of the plates, huge plates. There will be some plates which will be of the size of our India or any Pakistan or Afghanistan. Such huge plates are there. So when such huge plates when they move among between themselves, they release huge amount of energy, which that energy through the surface, which it travels to the surface of the structure, to the surface of the earth, and it will hit any structure which is which is standing in its way. Uh, and those type of waves, the earthquake energy released in the form of waves. So those waves, when you study here earthquake, you have here, see, the back and forth motion produced as p waves travel along the surface can cause the ground motion to buckle and fracture. S waves, we have P waves, S waves. S waves, or these waves cause the ground to shake up and down, and side waves. So you can say that the P waves, they will produce a horizontal movement for any building, and whereas your S waves will create this vertical movement of any building. And the third figure which we can see here is one type of surface waves moves the ground from side to side and can damage the foundations of the buildings. See, main your building is resting on the foundations. When once these earthquake waves are hitting the ground, and when they are affecting your foundations, when once the foundation failed, your total building collapse. So these, especially the third one waves which we were discussing, they can damage the foundation of the buildings. And another type of the surface wave travels along the Earth's surface, much like rolling ocean waves. The arrows show the movement of rocks as a wave passes. The motion follows the shape of an ellipse. So here, when you consider this second and the fourth figure, you have in the second figure only the vertical movement, whereas in the fourth image you have this ocean type of waves hitting your surface. May God help all of us when He should save all the human beings from this type of waves and this type of energy releases from the earth. But at the same time, we should be ready. We should be ready for such type of catastrophes. And especially these days we have seen lot of improvement in the people reaching out to the engineers, taking the designs. Even sometimes we think that it's a residential building, no need of any design for that structure. But dear friends, see, we should not neglect this type of this type of things. When we are going to spend around 1 million rupees on our construction of the structure, at least we can spend some 20,000 rupees on its design, where an engineer can give you the proper dimensions as per the local conditions, local conditions, seismic conditions. Now, for earthquake load, so we have here P waves and S waves as we study in our previous slide. Here we can see that there are three type of we have shown here three type of earthquakes. One is Palmer, Alaska, and another is Golden, Colorado, and another is Bogota, Colombia. So these three earthquakes, see, you can see that in this Palmer we have mostly P waves, and also here in the second one, Golden, Colorado, here we have P waves are there, and S waves also we can see here. And whereas in the third one, Bogota, So you have surface waves. Yani the third one is the most crucial one, which has caused a lot of damage. Now we have here surface waves when it is hitting the structure, and this soil plays a very important role, because soil, sometimes you have very soft soil, sometimes you have very stiff soil, and the structure which you can see here, there are some body waves are there. So as your as the soil becomes stiff, so effect of your earthquake loads will not be much heavier as compared with the soft soils. Here the fault rupture is there, see, body waves when we are moving. So the type of the soil also is very important in your in studying the result due to the earthquake waves. Here you can see one image here. In the seismogram we have different waves here. When we have got solid bedrock, and another is well consolidated sediment, poorly consolidated sediment, and water saturated sand and mud. So here you can see that the structure which is the structures which are standing on this solid bedrock, they have got very mild vibrations, whereas the structures which are having half of its solid bedrock and half of the well consolidated sediment, you have got a moderate effect. And where the structures are resting on the poorly consolidated sediment, you have very strong effect of the earthquake. And the structures which are very near to the water bodies, water saturated sands, they have got severely affected. So these are the effects due to the earthquakes. That's why most governments, they will not allow the people to settle near any water bodies. Especially we have seen in our area, Vijayawada, when this government have passed this GO that near this Krishna river, whoever they have habituated, they have constructed their houses or any commercial establishments. So they have to take special permissions from the government, and they have to take special design, because due to this effect only. So welcome back, dear friends. So now the earthquake study for this, we have one case study here, 1.6 mile Ling Cyprus river structure, and the earthquake which has been occurred in 1989, that is called Loma Prieta earthquake, magnitude 6.9, and in Oakland, USA. So here when you can see this structure, Cyprus structure, it's an you can say that it's a flyover structure, and some part of that is standing on the soft mud, and some part is standing on sand and gravel. And post earthquake, we can see, after the post earthquake, we can see here that some part of the flyover is standing still without any damage, and another part has been damaged completely. Now friends, when we come when you see the difference between this wind and earthquake forces. Wind forces are, you can say that it's a force type loading, the load which is acting on the surface of any structure, because you need a surface, right? You need a surface for any loads and wind loads for acting. Whereas the earthquake loads, they are called displacement type loading, because once the earthquake waves, when they travel through the ground, when they hit any structure on its way, so the structure will try to stand against those waves with its inertial force. And when these waves, and when this energy, seismic energy hitting the structure, when the inertial forces cannot handle this force, then there will be a displacement will be happening in the structure. So we can study deeply in the coming inshallah presentations. So mainly the wind is a force type loading and earthquake is a displacement type loading. Now you can see here this the same difference between the wind and the earthquake loads. In the earthquake loads, you have a reversal of the forces in a very short period of time. You can see here a graph A for the wind load, for the earthquake loads. Whereas for the wind, the reversal of the forces, they will be for a large period of time. Especially when you read this American code for the wind loads, you have a 3-second gust period. 3-second gust period. So in that 3 second, it was called a fluctuating force of the wind is been considered. That's why it's called a 3-second gust period. And coming to the next slide, next slide we have got blast loading, impact loading, and machine vibrations. Machine vibrations, so inshallah we will study deeply in the future presentations, where we have different type of machines there which have different type of motions, like we have harmonic motion, sinusoidal motion, and different type of loadings, like response, linearly changing variable response, and non-linear response. Inshallah that will be studied in the coming presentations. Now finishing for this dynamic loads, see, they produce acceleration in a body, so that means the change of velocity with respect to time is not equal to 0, and they always varies with time. Whereas for example, we can see our universal testing machine is there. So when you apply the load on any concrete cube or any rod, so when you apply the load, you will apply this load very slowly onto the structure. So there's not even if it's a moving load, but you cannot say completely it's a moving load, because here acceleration or application of the load is very slow. So dynamic loads which are exerted by the rotating machines. So these are the machines, when you keep some machines on the top of the structures, they induce lot of forces. Okay, they are called harmonic forces due to this unbalanced forces due to this movement of the machines, and such as for example turbines, you have electrical motors, you have electrical generators. Sometimes we keep electrical generators on the top of the buildings, and some fans, rotating shafts, and unbalanced cloth. For example, unbalanced cloth in a drum of rotating washing machine is also called a harmonic motion. Inshallah, in the next slide we will study deeply what the harmonic motion is and what are its advantages, how the harmonic motion can be represented, and how these forces can be analyzed, how these forces will going to affect your structures. Till then, Allah Hafiz, bye, take care.